Hello students, today we will study optics chapter. So let us see what is optics. Optics is that branch of physics which deals with the nature and sources of light, its properties, vision and effects. In fact, optics is divided into two parts. One part is geometrical optics, another part is physical optics. And geometrical optics concerns the rectilinear propagation of light, in which we study about the reflection and refraction of light. So basically, geometrical optics treats the reflection and refraction of light. We study here the light in the form of rays, but in fact, light doesn't travel in the form of ray. It travels in the form of waves. So here we will study about the ray nature of light, and this is possible only when the wavelength of light is much less than the size of the obstacle which we want to see. Therefore, the condition is that the wavelength of light must be very less than the size of the obstacle. Okay, so in geometrical optics, we study about the phenomena of reflection and refraction of light. And here, one important condition is that light used must have wavelength very less than the size of the obstacle. So this is the pictorial representation of the ray of light. A ray of light is, it can be defined as, it is an assembly of photons. Photons are the smallest part of light. It is the smallest packet of energy, which is also known as the quantum. It is the minimum amount of light. So this is the ray nature of light, and this is the wave nature of light, and this is the photon picture of light. Photon picture of light. So this is the ray nature of light, this is the wave nature of light, and this is the photon picture of light. We can say that a ray is an assembly of photons. So we will study about photons in detail later in photoelectric effect chapter. So another part of the optics is physical optics. It has two parts, again wave optics and quantum optics. In wave optics, we study about the phenomena of interference of light, polarization of light, and interference, polarization, and diffraction of light. So these are the three phenomena which we study in wave optics. Therefore, what we see, optics is broadly divided into two parts. One is the geometrical optics, which treats the rectilinear propagation of light, in which we study about the reflection and refraction of light. Another part is the wave optics, and third part is the quantum optics. So in wave optics we study about the wave nature of light. In quantum optics we study about the photon nature of light. Now let us move ahead and let us see what is the review of light. Point number 1. Light is an electromagnetic radiation. Light is an electromagnetic radiation. It is not deflected by the electric or magnetic fields. Third one, its speed in vacuum is 3 into 10 power 8 meter per second. The speed of light in vacuum is 3 into 10 power 8 meter per second. Light is just I'm reading, light is an electromagnetic radiation. Light is not deflected by electric or magnetic field. Its speed in vacuum is 3 into 10 to the power 8 meter per second. Light is a transverse wave. It is a transverse wave and hence it can be polarized. Polarization means to reduce the intensity of light. Like we use goggles, धूप वाला चश्मा यूज करते हैं, लाइट की इंटेंसिटी हमारे आंख में कम पड़ती है तो इरिटेशन नहीं होता है. तो polarization means to restrict the any of the vibration of the light to reduce the intensity of light. So light is a transverse wave. It can be polarized. And light is not deflected by electric and magnetic fields. Okay. Now let us see what is an electromagnetic spectrum. Electromagnetic spectrum. We want to see where is the light in electromagnetic spectrum. So we start from gamma rays, X-rays, ultraviolet rays, visible light, infrared rays, microwaves and radio waves. It has two parts, short range wave, long range wave. Gamma rays are more powerful, gamma photons have more energy, and according to Max Planck, the energy of any photon is directly proportional to its frequency, or we can say that E equal to h nu. H is the Planck's constant, nu is the frequency. So the gamma rays have the highest frequency. And the wavelength is very small. So here from right to left frequency is increasing, and from left to right wavelength is increasing. Lambda is the symbol for wavelength. So the maximum wavelength is for radio wave. It has two parts, short range wave and long range wave. The visible light is in between the ultraviolet region and infrared region. The minimum wavelength of the visible light is 4,000 angstrom to 7,000 angstrom. 1 angstrom equal to 10 power minus 10 meter equal to 10 power minus 8 centimeter. Angstrom is the unit of length. Small length is measured in angstrom. 1 angstrom equal to 10 power minus 10 meter equal to 10 power minus 8 centimeter. So this is the visible light, and these are the radiations. These are not visible, and the speed of all these radiations are same, 3 into 10 power 8 meter per second. The difference is in the wavelength and the frequency. So this is an electromagnetic spectrum. Gamma rays are more powerful than X-rays. X-rays are also electromagnetic radiation. Ultraviolet rays are also harmful, and infrared rays are produced by hot objects. Microwave, we know that it is produced in the microwave oven. It has a lot of uses, and radio wave is also used in our telecommunication system. And X-rays are produced by Coolidge tube. X-rays are nothing but the fast moving. When the fast moving electrons are stopped by a metal target, secondary rays are produced, and these rays are X-rays. Okay, now we move ahead. Let us see some of the properties of light. Our eye is more sensitive for yellow green light. This is one property. Number two, the persistence of vision is 1 by 10 second. If you want to distinguish between two light pulses, suppose two light waves are traveling along the same direction, and if you want to distinguish them separately, then how much time is required by our eye? 1 by 10 second. 0.1 second is required. So 0.1 second is the persistence of vision. You might have seen in the bioscope. बचपन में आप बाइस्कोप देखे होंगे, उसमें दो फिल्मों के बीच में ज्वाइंट होता था. तो एक में अमिताभ बच्चन ऐसे उठाया, दूसरे में यूं 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 करते हुए पूरा पिक्चर बन गया. ज्वाइंट दिखता नहीं था क्योंकि उसका स्पीड जो है ना, स्पीकर का स्पीड बहुत तेज था. इतने सेकंड से कम समय में उसको आगे बढ़ना था. तो ये है परसिस्टेंस ऑफ विजन, विच इज 1 by 10 सेकेंड. अनदर प्रॉपर्टी इज resolving limit of our eye. Resolving limit of our eye is 1 minute. If you want to distinguish between two point objects which are very close, our eye requires 1 minute to resolve. So we say that the resolving limit of our eye is 1 minute. Let us study some of the more properties of light. There is no effect in the speed of light. For what? If the relative motion between the source of light and the observer is v, then c plus minus v equal to c, because of the large amount of, because of the very high speed of light. If we add or subtract the relative speed between the source of light and the observer, it will have no effect on the speed of light. So there is no effect in the speed of light of what? Of the relative motion between the source and of light and the observer. Next property of light we want to study is when light passes from one medium to another. Let us write, when light passes from one medium to another, its speed or wavelength may change. Speed and wavelength may change. Its amplitude may decrease or remains the same, but the frequency of light does not change. When light passes from one medium to another, its speed and wavelength may change. Wavelength बदल सकता है, speed बदल सकता है, because we know that light travels with different speeds in different media because of the difference in the refractive index of the media, which we will study later on. So when light passes from one medium to another, its speed and wavelength may change, its amplitude may decrease or remains the same, but frequency of light does not change. Frequency of light does not change. You can ask that why the frequency of light doesn't change when it passes from one medium to another. I want to explain it on the basis of one example. We should know that whenever light falls in any object, a part of light is absorbed, some part is reflected, some part is diffracted, some part is polarized, there is also interference. So when light passes from one medium to another medium, when light falls in a medium, optical medium, or it may be some other medium, the atoms or the particles of the medium start vibrating with the same frequency as that of the frequency of the falling radiation. The frequency of the falling radiation, suppose it has some particular frequency and it is falling on an object, on the surface of an object, the particles of the object, the atoms of the object will vibrate with the same frequency. And whatever light is reflected, diffracted, or any phenomena is there, those will have the same frequency. That is why the frequency of light doesn't change when it passes from one medium to another medium. The speed may change, wavelength may change, amplitude may remain same, or it may decrease. Intensity also changes because the intensity of the light is directly proportional to the square of the amplitude. The intensity is directly proportional to the square of the amplitude. But one property, one characteristic property of the light doesn't change. That property is the frequency. Frequency doesn't change. And we should know that the color of light is determined by its frequency, not by its wavelength. Please write it. The color of light is determined by its frequency, not by its wavelength. Let me write here. The color of light is determined by its frequency, not by its wavelength. So today we will learn up to this, and in next session we will start some other things. Thank you very much.